Oh, hi there. Thanks for showing up for your learning. Here we're going to look at how you can solve for the rate that's required to move a certain amount of money from one amount to another amount. If Caleb is going to invest 120 bucks and he needs 300 bucks in 18 years, and the interest is compounded quarterly, what interest rate does he need in order for him to get 300 bucks? Why are we answering this problem? Isn't it just easier to go out and earn the $180? Like, it's not that big a deal. But anyway, we can absolutely solve this problem. So let's do just that. Let me call up here our worksheet from today, and it's got a reorganization of our equation. Future value is equal to the principal multiplied by 1 plus r over c to the ct. And if we reorganize that equation, we do get this fancy equation right here. The rate is equal to the compounding frequency multiplied by the ct root of fv over p to the minus 1. All right. So one thing we can do is copy out that formula onto a blank piece of paper. Let me get that open too. Thank you for your patience. And that will look like this. So the interest rate is equal to the compounding periods multiplied by the CT root of future value divided by present value minus 1. Okay, and that's the formula for the rate. So in this case, we know his principal is 120. His desired future value is 300. Okay, his interest rate is unknown. C is the compounding frequency. We said quarterly, so that's a 4. And T, the number of years, was what, 18 years? It's really testing my memory. Let's see. Yeah, quarterly, 18 years. Yeah, so this will solve for the interest rate. So this is how we can just plug it into a formula. So R is going to be equal to 4 multiplied by 4 times 18. That's subbing in for CT. 4 times 18, I want to take that root of 300 divided by 120 minus 1. Okay, that's everything. So now let's simplify as much as we can before we go to the calculator. R is equal to 4. Got to do that later. Multiplied by 4 times 18 is 72. Very nice. The 72nd root of, so interest would be applied 72 times in that time. So this is going to solve for the growth factor in here. 300 over 120 is 30 over 12. 30 over 12 is the same thing as 5 over 2. 72nd root of 5 over 2 minus 1. Okay, now I can't do that in my head. I don't know that anyone can. So let's go ahead and do it on the calculator now. Okay, so here, I'm going to clear everything. We want the, do I have the nth root? Let's see. Yes, there I go. The 72nd root of bracket 5 divided by 2 and the bracket equals. Well, that is not correct. Okay, that's not correct. So, clear. I need to do it in the other way. I don't like it. So I'm going to do the other thing. I'm punching this on my calculator. So I'm going to, and just rewrite this as R equals 4 multiplied by 5 over 2. And this would be my instincts normally. Raise it to the power 1 over 72. Is the same thing as taking the 72nd root. That I know how to punch on my calculator. I just learned how to punch the nth root on my calculator, but I didn't like it. I'm never going to do it again. So just going to punch that in. Let's move me, because I'm useless, down here. Let's go. Okay, so 5 divided by 2 equals 2.5. And now raise that to the 1 divided by 72. It should be a number very, very close to 1 equals 1.012. Okay, going to subtract 1 from that equals, multiply that by 4 equals. That's the result of all of that math. 0.0512, so about 5% is required for him to achieve his investment goals. 5% is a reasonable interest rate, so I'm quite sure we're correct. Let's see, they wanted it to the nearest tenth of a percent. nearest tenth of a percent. So that would be 5.1%. See it there? Good. 5.1, enter, enter. Hooray! Here's another way you can solve these types of problems, okay? Throw it all into Desmos, okay? So we're gonna have R, our interest rate, is equal to, and then you can say C, the compounding period, multiplied by, put this in brackets, the future value divided by the principal, end your bracket, and raise it to the 1 over CT. Okay. And then subtract 1 from that, and that's your formula. Okay, we can add the sliders, no problem. And then we knew that the C was 4, so just put that in. The future value desired was 300. The present value, the principal invested, was 120. And time was 18 years. And why am I seeing something with radicals and things like that? That's annoying. R, because R, let's call this I. There, I. Yeah, it didn't like R. R, it was like that's the radius of something or something like that. So I just had to jimmy around my number, my letters a little bit there to get Desmos to cooperate. I'm a little surprised it didn't like R. Okay, so R equals blah, blah, blah. And there it is, the same number, 5.1. Okay, now the nice thing about this is if I do yet another delta math problem, so let's do a new problem, compounded, I'm going to show you compounded continuously in a second. Let's do compounded daily here. Okay, Lincoln is going to invest $8.3 thousand. So let's put that in as our principal. So go ahead to Desmos. 8.3 is the principal. Sorry, 8300, $8,300. Okay. And now note that now our I is like a negative interest rate. That we're going to fix that in just a second. Oops. And delta math is over here, Mr. Jennings. Okay, and then it's going to be in there for 10 years, compounded daily. At what interest rate do we need to get 10,300 for it to grow by 2,000? So let's go ahead. We're going to go in here. The desired future value is 10,300. The compounding frequency is daily, so we're going to put 365 there. And the amount of time is 10 years. Click away here, and that gives us 0.0215. How much detail do they want? The nearest tenth of a percent. Well, this 5 here makes that last 1 round up, so it's 2.2%. Let's put that in, 2.2. You can solve a lot of questions quickly when you just use delta math and input your values. Desmos and input your values. You could also create spreadsheets to do these for you too. Okay, now, one type of problem that you're not going to be able to solve with an algebraic method at this level is when we're compounding continuously. For these, this is what I recommend you do. Okay, clear all this stuff out. You're going to start with your interest formula for continuous compounding. P is equal to, future value is equal to the principal multiplied by E raised to the power RT. And you can input for, and instead of R, let's use X, because that's what we're solving for. And Desmos is naturally going to like it if we put in X there. Okay, it's going to tell us what interest rate we need. Okay, so I'm going to go ahead, look at reasonable interest rates in there. And let's see. We want, and I'm going to have to zoom way in. I'm really zoomed in one moment. So now let's go and find the other things that we need here, like P and F. So we can actually divide both sides by P. So let's do that. We'll get that over there. And then we'll just divide this by P. Let's do it that way. And then let's see if it will work for us. I'm actually kind of playing around with this myself. I'm not sure if this is going to work. $1,800 we're going to invest. Actually, we don't need to do that. I lie. Equals P. So we want to invest P equals 1,800. Okay. And then F equals 2,400. So let's try that. f equals 2,400. So we're going to need to be able to see up to that high in the y. So let's put in 4,000 is good. There we go. And let's, instead of using f, let's just use y, 2,400, y. Y equals that, and y equals 2,400. So there's where we want this function to hit. Okay? That's the value we'd want this output to be. And we need to have the value t time. Okay, so what is time? 6 years. So go ahead and put that in there, 6. So boop. And then we can have here p is 1800. There we go. And it turns out that if the this is 6x there. So it turns out that we need an x value of 0.048 for this to work out. 0.048. So that's how I would do it. All right. Here is an function that shows as the interest rate increases, how fast my money is increasing. And I want my money to get there. So I needed to increase the interest rate right to there. And that's what it is, 0.048. So I'll put that in. 4.8%. Hooray. Let's do another one. So compounded, no, I want continuously because you may see these problems. Jason is going to invest $720. So I go in here, my principal is 720. So put that in. How many years? For 6 years, so that didn't change, and we want $930. Okay, so we're going to put in here y is equal to 930. We don't need this. And now we just go over here and we find what interest rate gets it done. Oh, wait. I need to zoom way in because it's a very small number for x. And it's there, 0.043. So that's the interest rate that we need, 4.3%. To the nearest hundredth of a percent, 4.3. Do I need more detail? I think I do. So I'm going to expand the this here to look at just x values up to 0.5. And this down here, we don't need any of those, just 0.1 is fine. There. Now this will give me more. See there? 0.427. Perfect. To the nearest hundredth. Okay. Of a percent. 427. That's how I would do those and solve for the rate. Any questions? Hit me up by email. With a screenshot is great. Otherwise, thank you for showing up for your learning, everyone. Where's the off button? Up here. Bye.